Hi, it's Seta here. Welcome to the fifth part of the course about Unity water system. And this time I explain how the special shader used to deform the water surface work. This is the last theoretical part of the course, so if you haven't watched it from the beginning, I recommend do it, as it explains all the options and settings currently available in the Unity water system. Especially since in the upcoming videos we will focus on the practical use of this knowledge, but without explaining every options again. So let's get started. Now let's deal with deformers. In other words, are special materials that allow us to manipulating the shape and height of the water within our decals. At the beginning, remember to have the deformation options checked in the water decals on our water, as well as properly assign the region and its size. Of course, we can leave this field empty, then, as I mentioned before, this region will follow our camera. Now, let's add water decals to our scene. Right-click in the hierarchy window, Water Decals. Let's change the update mode to real-time to have a live preview of our decals on the water, and then let's set position and scale. Now click on the New in the material window and select Deformer and Foam Water Decal. A new material will be created. Of course, the shader used in the material is created in shader graph, so we can freely edit it, but now let's move on to the material options. First, we choose the type of our deformer. Keep in mind that for each type of deformer, we have special options that we can control. The other options, although available, will have no effect on this particular type of deformer. In the HDRP water system, there are 5 types of deformations available for the water surface. Each of them is used for different purpose and has different properties. The first type of deformer is sphere, and it's a type of water deformer that creates spherical deformation of the surface, meaning it pushes or lowers the water within a spherical radius. This is the simplest form of the deformer, and the only things we can control here are its amplitude and size. Next, we have box deformer, which creates a square-shaped deformation. Here, except amplitude and size, we can control how far from the decal's edges the deformation should reach its full height. In simpler terms, this allows us to control the slope of the sides of the square in relation to the water surface. Below that, there is a cube blend options, which let us decide whether the slope should be more linear or more rounded. The next type we can choose is bow wave, which is a special type of deformer for the bow of a boat or ship. Besides height and size, here we can also control the elevation to rise or lower the water level in front of the bow wave, which allow us to simulating the effect of pushing or lowering the water by a boat bow. Then we have shore waves, which is the type of deformer that simulates shore waves. First, we have the wavelength, which we can specify how long the wave should be between its crest and tail. Using skipped waves, we can specify how many waves should be skipped and not generate in our water, which helps prevent waves from being too close to each other and creating an unnatural effect. The next option is wave speed, where we can set the speed of our waves. Remember that the speed of those waves also depends on the time multiplier in the general section of our water, since the time multiplier defines the speed of the entire water simulation, including the simulation of our deformers. Using wave blend, we can specify the range in which the crest of our wave reach its maximum. Simply put, here we define how much the sides of the wave should be flattened from the left and right before reaching their maximum. If we imagine that the entire length of our decal is 100%, Then setting x to 0.5 means that the left slope of the wave front will reach its maximum height in the middle of the wave only at breaking point, where the rest of the wave will reach this height much faster. Next, we have offset, where we control the offset of our waves. This is useful when we have many decals generating waves, because if we don't change this, all waves on each decals will be generated at the same time, but using offset we can delay the wave on a given decal. The next option is breaking range, where we set the breaking point and the point where our waves will lose 70% of their height. The breaking point is also the point where our waves reach their maximum height and the foam on the wave surface will start generate. This is also the point where the upper point of the slope that we set in wave blends will reach their maximum height. So, in the x-axis, we can set the location where the wave breaking should start. And again, if we imagine the width of our decals as 100%, setting x to 0.2 means that the breaking point happens after the wave passes 20% of the decal's weight. And on the y-axis, we set the point where the waves will be too small to generate foam, and between this point and the breaking point, their waves gradually decrease its height until they reach only 30% of the original height. So if we set here for example 0.7 and the breaking point is set to 0.2, then when the wave passes 20% of the way, it will start breaking and gradually decrease its height until it passes 70% of the wave. It's a bit complicated, but I hope that you understand how this works. Then we have deep foam, where we control in which range of our decals the deep foam should appear. And just like before, the x value defines the point where this foam starts to be generated, and the y value determines point where its generation should end. The last type of deformer is texture, where in the deformation texture window we can place a specially prepared texture. Thanks to it, we can give any shape to our deformer. Such a texture can be created in any graphic program, and then after adding it to Unity, we must only change its wrap mode to clamp, and now we can assign this texture without any problem. Using remap minimum and maximum, we can freely manipulate height and base of the deformer. Below we have foam texture. Thanks to it, we can specify in our deformer where the foam should appear. The black color completely suppresses the foam effect in a given area, where the lighter color, the more foam will be generated in that place. And with this, we have finished the basic course of the water system in Unity. Thanks to it, you already know how to use each options and what they do. In the next tutorials about the water system, we will focus more on the practical use of this knowledge. So if you haven't subscribed the channel yet, I encourage you to do so. And of course, if you have any question, write them in the comments below. And until next time, see ya!